All right, picking up where we left off. I finished number 13, so let me start on 14. And hopefully this video will be more than 8 minutes long. 4 seconds or a joke. Okay. Y equals e to the xy. Okay, so if we are taking dy dx here, or y prime, we could say y prime is equal to, well, the derivative of this is just itself, except we are going to have to multiply this by the derivative of the xy, the inside stuff. So we might need to think about the derivative of xy for a minute, because it's not just each of these separately, it's a product. So I'm going to have to do a product rule. So derivative of xy right, we're going to do the first one prime, which is just 1. And remember we said that x prime is just 1, y prime is, we leave it as y prime, or 1y prime. So xy is going to, so we got 1, we got y, then I'll leave the x alone and I'll do the y prime. So here we'll have e to the xy times 1 times y is just going to be y plus xy prime. Now I'm tasked with getting y prime isolated. So if I'm doing that, I probably want to distribute here and get y e to the xy plus xy prime e to the xy, because now I can move this term over to the other side. We'll be able to factor out a y prime and then divide. So gross, but not that bad, honestly. Y prime minus x y prime e to the xy is equal to y e to the xy. Then we'll factor out a y prime and get 1 minus x e to the xy, and that's what we'll be dividing by. So we'll divide by that and get y prime is equal to y e to the xy over 1 minus x e to the xy. Okay. Good old classic gross derivative. Okay, let's see. Okay, 15 looks like it has a lot of pieces, but none of them are particularly complicated. I guess saying the word complicated is complicated for me today. Okay. 15 sine 2x plus cosine 3y is equal to cosine 2x minus sine 3y. All right, well, let's just be careful here. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of cosine is negative sine. Derivative of sine, well, it's a minus, so minus cosine. And then we got a 2x in here. We got a 3y in here. We got a 2x in here. We got a 3y in here. Derivative of 2x is just 2, so a 2 will pop out. Derivative of 3y will be 3y prime, so a 3y prime will pop out. I'm going to move the minus over there. Derivative of 2x is 2, so it's a 2 with a negative on it. 3y is going to be 3y prime, so there's a 3y prime that pops out. I'll move the minus over here. Okay, so we want to get y prime by itself. We can put it on either side, doesn't matter. I'll add the 3y prime cosine 3y to both sides, and I will subtract the 2 cosine 2x from both sides. So I'll get 3y prime cosine 3y minus 3y prime sine 3y is equal to negative 2 sine 2x minus 2 cosine 2x. as we go through problems like this, it is super easy to drop negatives, to miss little things here and there. And I'm hoping as I record these that I'm not making blunders like that, but it's so hard to see when you're in the middle of it. So I personally like to do a little bit of shortcutting here. So I'm gonna be pulling a y prime out. So if I pull a y prime out, then that's gone, and that's gone, and that's what's left. And that's what I'm dividing by. Like, you don't have to show me all those steps. If writing them helps you be more organized and helps you correctly solve the problem, then by all means write it. And I had to find my own balance when I was a student of writing things or leaving things out. Because sometimes I would leave things out and make silly mistakes in the process. And sometimes when I'm explaining these, I make silly mistakes because I'm not spending enough of my focus on what I'm writing. I'm trying to talk about it at the same time. I hope that I'm right. I'm sure that inspires a lot of confidence in you. I hope that I'm right. All right, let's see, 16. Y is equal to x to the x. I don't think I remember how to do this. I'm not pausing right now, though. The only way that I can think about doing this is if I ln both sides. Ln y is equal to ln x to the x. Oh no, got fuzzy. Okay, we're fine. If I do that, then I haven't taken any derivatives yet. I've just taken the natural log of both sides, which you're allowed to do. But I can bring that exponent out front. So I could say x ln x. This is pretty straightforward. I mean, compared to, I don't know what to do here. So if we're finding the derivative of this, which should be the same as the derivative of the beginning, well, over here we'll get the ln of y is going to be 1 over y, and then the derivative of the y on the inside is going to be our y prime, so I'll put a y prime on top. I do not like how much it's kicking out of focus. Here I got to do product rule, so I do the parentheses for teaching. You don't have to write them, but I think for some people they might be helpful. So I'll take the derivative of x, and on this one I'll take the derivative of ln x, and then we'll leave the other ones alone. Oh, hey, look at that. Over here we have ln x plus x times 1 over x is just 1. And so this is y prime over y. So we'll just multiply the y to the other side and get y ln x, I should have been using the little cursive thingy, plus y. Which I could spend a while thinking about this derivative and how this is really interesting, but that's not what you're here for. All right, let's see, 17. Y is equal to 2x plus 1 to the sine of x. This is going to let us practice what we just did a second ago. That exponent, since it's not a number, it's a differentiable function. We're going to have to do the same kind of thing. So we'll ln both sides. Ln y is equal to, now, since I'm going to ln both sides like I did in the last one, I did ln of x to the x, and the x just came out front. That's going to happen here. If I write ln, or like maybe what you would do in your own work, you could do ln y here and ln that here. Like, I'm trying to figure out ways for you to write less steps, and that's So now my next step, I'll put the sign out front and say sine x ln 2x plus 1. So the left-hand side is going to work the same as it did in the last problem. We'll say y goes on the bottom and a y prime is going to pop out and go on top. And here, we'll just do product rule. So sine x turns into cosine x. Ln 2x plus 1 is going to be 2x plus 1 goes on the bottom, and a 2 pops out on top. And then we just leave the other things alone. So final step, we'll just bring the y over. I guess I should have put that 2x plus 1 in parentheses there. So we'll say y prime is equal to y cosine x natural log of 2x plus 1 plus, well, the y is going to go here, right? And with the sine and the 2, so they're all on top, and the 2x plus 1 is on the bottom. So I'll put 2y sine of x over 2x plus 1. So this nice, disgusting derivative. Derivatives are great though, because like you just follow the steps and you get the thing. It's not like an integral where you have to kind of guess what the answer is going to be. All right, 18. More of the same team, 18. All right, and I'm just going to go to the end of this page just for the end of the video. There's the paper, okay. 18. Y is equal to sine of x to the e to the x. I want to see what this function looks like, but I'll do that on my own time. This has got to be bizarre looking. Okay. Same thing, right? Natural log of y is equal to e to the x natural log of sine of x. Man, jeepers. Is there something on my screen? On my, not screen, lens? This normally stays focused for me really well. Oh dear. Okay. Well, let's take our derivative. Over here we got our y prime over y. Over here, product rule. So derivative of e to the x is e to the x. Derivative of ln sine x is 1 over sine x. And then the derivative of the inside is cosine x. So cosine x goes on top. And then we just leave the friends alone. So leave the ln sine x alone. And then leave the e to the x alone. All right, and then we'll multiply by y. A y will slap on here, a y will slap on here. I would accept this as your written final answer as well. So let's clean this up a bit. I would write y e to the x ln of sine x plus y e to the x. Cosine over sine is cotangent. So that's what I would personally write for my final answer. The previous stage would be acceptable as well. Okay. On to second derivatives. Find d2y dx squared. This is going to be a common problem this year. We're going to run into strange second derivatives. Oh, the first several of these are not strange though. All right, so Our first derivative here is going to be y prime, and y prime is going to be, well, the derivative of secant squared is secant tangent, so that's secant 4x tangent 4x. And then the derivative of the inside is 4, so a 4 pops out. A lot of times my students get confused because they write 4x twice here. They're like, do we need to do something with both 4x's? And no, because the derivative of this is secant tangent of the inside thing times the derivative back here. The 4x's that happen here are like a result. They're not creating the derivative. They're not creating that 4. The 4 gets made from this thing here. So now when we go to do second derivatives, now we're going to have to use both of them, but we're going to use both of them in their own time. So a couple ways to handle this. One is to put a 4 and then a big parentheses and do everything inside. Another way is to put a 4 before each of the things, because it's a constant times the function, times this differentiable stuff. So I think I am just going to stick with that. I think that's going to be a little easier to look at. So inside I'm going to do product rule. I did not leave myself enough room in that. It's fine. It's fine. It's fine. Everything's fine. So in our first one, I'm going to leave tangent 4x alone. And then our second one, I'm going to leave secant 4x alone. Derivative of secant 4x, I did that a minute ago. It's this whole thing. So 4 secant 4x tangent 4x. And then here, the derivative of tangent 4x. Well, remember the derivative of tangent is secant squared. So this is secant squared 4x with a 4 on the front. Cool. This is worth cleaning up. Like these kinds of things are multiple choice questions a lot of years, and it's not super bad to clean up. So we are going to distribute the 4 to everything. Oh, they both end up having a 4, right? There's a single 4 as a constant out front and a single 4 as a constant out front. So then that means that both of these are going to say 16. This one, I have a secant 4x, and then I have tangent 4x, tangent 4x. So I could rewrite that as secant 4x, tangent squared 4x. And yes, technically there are parentheses around those. I'm used to seeing them left off when it's like this. It's kind of understood that they're in parentheses, but if that's helpful, again, just do it. And then we have secant 4x and then secant squared 4x. Oh, so that's 3 of them. Secant cubed 4x. And that is our y double prime. Whew. That's what I'm imagining many people feel when they see this kind of stuff. For whatever reason, this is not strenuous for me. Plenty of things we do are tricky, but like just, I don't know. Maybe it's because I like being like a robot and just going through and following the directions. Let's see, 20. Man, what a jerky flex. Hey guys, I'm filming this video to help you with your math. Let me tell you how easy it is for me. I do this one in my sleep. All right, let's see what y prime is on this one. Y prime just chills. It's e to the x. It stays the same. And then the derivative of the inside pops out. And I didn't leave myself, no, I did leave myself enough room, because the derivative of 2x squared minus 1 is just forks. That's our y prime. Our y double prime, we'll do product rule. Yeah, so this is the alternative. Instead of having 4 out front of everything, you can have 4 be like part of one of the terms. And it'll work the same. So let's see, derivative of 4x is 4. Leave the other stuff alone. The 4x stays alone, and then the derivative of the e to the 2x squared minus 1 gets differentiated is the actual verb we would use. And then a 4x pops out, so it's going to be, boom. So I'll clean this up. Our y prime then is 4e to the 2x squared minus 1 plus 16x squared e to the 2x squared minus 1. All right, 3 more. All right, 21, which is French for 21. ln of x plus x squared. All right. So, well, we know the derivative of ln is 1 over the inside stuff, and then times the derivative of the inside stuff. Oh, I'm so sorry for... But I'm not going to do anything about it. I'm just going to complain that my phone is annoying. So 1 plus 2x goes on top. Great. And then, second derivative. Yay. Quotient rule. So I'm very particular about the way that I show when I do product rule that I'm doing first, second, second. That's important to me because I have so many students that mix up which one goes first. So first goes first, which top is first, and there's like a connection in my mind. That keeps it super simple. The top derivative goes first, which is 2. Leave the bottom alone. The bottom derivative goes next, 1 plus 2x. Oh, see, I don't like writing it like that. I like to write the bottom derivative here when I'm teaching to like really emphasize we're doing the first derivative here, the second derivative here, and the other thing stays the same. It doesn't actually matter. Oh, wait, that's fun. The derivative of the bottom is the, I should have seen that coming. All right, and then down here, we just write the bottom squared. This is fine. I'm gonna clean it up, but it's fine to leave it like that. So let's see, I'll write 2x plus x squared here. I'm just gonna leave this as 1 plus 2x, the quantity squared, because oh yeah, no, okay. So like I did a little bit of cleaning, but not a lot of cleaning. Story of my life. All right. Two more. And these are where they get a little sticky. Twenty-two. Y is equal to x plus y squared. Okay. So, if I take the derivative just as it is, I get y prime is equal to 1 plus 2y, y prime. And there are several ways forward here. One of them is just take the second derivative as it is. But you'll find out that leaves you with extra y primes that we don't want to deal with. We want this to just be in terms of x's and y's, not dx, dy, and stuff like that. So what I really need to do is first solve this for y prime by itself. So I'll subtract, I don't have to subtract everything, do I? I can leave the 1 here and just subtract the 2y, y prime. So y prime minus 2y, y prime is equal to 1. We can factor the y prime out here, 1 minus 2y. Then we'll divide and we'll get y prime is equal to 1 over 1 minus 2y. So y double prime. Y double prime then is, one way to handle this is quotient rule, but I would prefer to remember that 1 over something is the same as writing it to the negative first exponent. And so I can just use the power and chain rule here. Bring a negative 1 out front, 1 minus 2y to the negative 2. Then times the derivative of the inside, 1 minus 2y, which is a negative 2y prime. Now, we don't leave y primes in our answer. Fortunately, we know y prime is this. And so I can go and I can put that right there. I could rewrite this as negative 1. Oops. Let me write that the nice way. 1 over, why did I write that all in parentheses? 1 minus 2y. Hey, let me rewrite this line. Okay. So we've got a negative 1 over 1 minus 2y squared. There, much nicer. That's what I meant to write. And then the negative 2y prime. Oh, wait. Negative 1, negative 2 multiplied together. That's positive 2. Positive 2. And then we'll multiply by y prime. Y prime is 1 over 1 minus 2y. Oh, hey, look. I could rewrite that as 2 on top and 1 minus 2y cubed on the bottom. And that would be our y double prime. These are beastly. Or at least I'm going to tell you that these are so terrible. They can't get any worse than that. All right, let's look at the last one, 23. Sine y is equal to x minus y. Well, all right, we'll take our derivative. So we get cosine y with a y prime that pops out. And on the other side, we'll get our 1 minus our y prime. So just like we did in the previous one, we want to solve this for y prime first. So we'll add our y prime here to both sides. Y prime cosine y plus y prime is equal to 1. We'll factor out a y prime here, get cosine y plus 1, and we'll divide that over. So y prime is equal to 1 over cosine y plus 1. Okay. So, second derivative time. I did the last one using the power rule and chain rule. Let's for this one I will use quotient rule. So y double prime is equal to bottom squared goes there. Here, derivative of the top goes here, but it's just 0 because it's a constant. And then we leave this alone. Then here, the 1 leaves alone, and the constant, or the derivative of the bottom is sine y. Oh, negative sine y. Negative sine y, and then a y prime pops out. So this one, those negatives will turn to a plus. We'll have, oh, that's all 0. This is gone. So we'll have positive 1 sine y times y prime all over cosine y plus 1 squared. And so we're going to have to now substitute in 1 over cosine y plus 1. And remarkably similar to our previous one, we'll be able to, that now is going to flip down to the bottom. The sine y is going to chill where it is. And then so an additional cosine y plus 1 shows up there. So we get sine y over cosine y plus 1 cubed. And that would be our second derivative. All right, wow, it's just about 30 minutes. I hope that was helpful. Yeah, as always, if you have any questions, please feel free to ask. All right, have a good one, bye.